me just, okay, now I'm recording. But again, this is what we saw last time. I think last time we saw it. So I was just reminding you. But again, you can solve conversion problems using proportions. Okay, now I want everyone to try this. We want to know how many inches are there in 10 centimeters. Okay, and let me just start you off. So for centimeters, we have either one of these you can use. Okay, so we want to know how many inches there are in 10 centimeters, okay? So let me see. There we go. Okay, so again, I just want everyone to just, what do you call it, try it out for like a minute or two. You know, just give it a shot. If you don't get it, that's okay, but, you know, just try though, please. Here, let me just set the timer on my phone. Take a minute. Okay, you know, if you're using the factor label method, that's fine. But I figured it'd be good to have people try this out. Okay. Let's do it together. Okay, so we can use proportions, as I said before, you know, we're doing conversions. So we can use proportions. Okay, so we want to know how many inches there are in 10 centimeters, right? And we know from an earlier slide, this is the conversion I used. If you use the other one, conversion factor, I mean, the only difference is that yours would be, I think, inverted. So here I use 2.54 centimeters per 1 inch. So we have a unit rate here. Okay. So that's one rate describing the conversion. Here's another one where x is the number of unknown inches. But they're both equal to what we're saying. They're both equal to each other. Mostly because they both deal with the same conversion. So we want to figure out what x is. And again, wait, got ahead of myself. And again, you know, make sure the units are in the right spots. So centimeters for me is on top, inches is in the bottom. If you use the other conversion where you have 1 inch over 2.540 centimeters, then on the right side, this would be inverted. Okay, so here's what we have. Okay, and again, we want to figure out what x is. Okay, so what do? We can cross multiply, like so. Right, so again, this is what I did. Cross multiply. This is how we got the left-hand side. The right-hand side is just 10 times 1, which is 10. And then we divide. Oh, wait. As you can see, we divide. Okay? And then finally, this is where a calculator comes in. Come on. There we go. And so we get this, which is about 3.94. So, I mean, what I got was 3.94 inches. So I hope other people got that. Okay.
I said 3.93.
Let me make sure I didn't round wrong. Let me take a look real quickly. Did you do 10 divided by 2.540 like me?
Yeah.
Oh, because I got in my calculator 3.937.
I got.
So the thing is, you have to I said round to 2 decimal places. So
Oh.
7, you
Okay.
would bring the 3 to 4.
Okay. Thank you.
You're welcome. Awesome question. Any other questions or? Okay. All right. Okay. Now we get to do some fun word problems. Okay. So this one actually, I think it's from the book, although I think I might have modified it if I remember correctly. But so here's what we're given. We're supposing that we have these 4 3-megawatt wind turbines. And I'm guessing they're big. I don't know how big wind turbines are, but they're able to supply enough electricity to 3,000 homes. Okay. So now the question is, how many turbines are needed to power 55,000 homes? Okay, so we have this word problem. All right, so we want to, there we go. Okay, so we do have some kind of rate here, don't we? You know, the 4-megawatt turbines and 3,000 homes, right? So we can form a rate from that. You just divide. Okay, I probably should have put 3-megawatt, but I guess it's okay. We have these 4 huge turbines, that's given. That can power 3,000 homes. You know, that's given to us. I mean, yeah, I guess you could do a little bit of calculation and get how many homes one of these things can supply electricity to, but you really don't have to do that. And you could also you could also have done the inverse of this, say 3,000 homes per 4 turbines. We want to know how many are going to power 55,000 homes. So I'm going to call that X. I know before I didn't say let X equal or let X be. I thought it'd be really good to do that here. So X is how many of these turbines are needed to power 55,000 homes. Well, we can get another rate out of that, can't we? Right? We have this rate now. We don't know what X is, but that's okay for now. I mean, we're going to figure it out. But we have these 2 rates floating around, don't we? We have this, and we have this rate. Well, what's going to happen? Well, they're going to equal each other, mostly because they're both dealing with the wind turbines supplying power, you know, electricity to these homes. So they're going to be equal to each other. They're going to be equal to each other. You know, they both deal with the same thing. They're both involved dealing with supplying these turbines, supplying electricity to these homes. Okay, so we set them equal to each other. And now, as you could probably guess, this is how we're going to solve it using proportions. You could solve this if you wanted to using the factor label method. I just thought the proportions might make it a little bit easier, but this is what we have. Okay, so, you know, if you were to take the units away, or you can just cancel them, this is what we have. Okay. Now, what do you do next? Well, it's just like before. We cross multiply, like so. And that's what I'm doing. I'm showing all the steps, although I actually skipped a step here. Basically, what I'm doing here is I'm cross multiplying both sides. So in other words, I didn't show the step, but we would have 55,000 times 4 on the left side, 3,000 times X on the right. But then you could divide by 3,000 to get this. Unless I skipped this step. No, I didn't. Good. Oh, okay, this came too early then. This is what we would have directly. Okay. Then we would have this. Sorry, these two got out of order. I don't know how I missed that. But either way, what's going to happen is we're going to get this. So this should come first, actually, before this one. Namely, we have 4 times 55,000. That's equal to 3,000 times X. You know, these cross multiply. multiply. Then this, you would divide by 3,000, and then you would get this. Okay, and it turns out you get about 73 wind turbines. So it's about 73. Although I guess one can really argue you would need more than that because it's 73.33. But I rounded it to 0 decimal places. I mean, I would tell you how many decimal places to round to. So, all right. Okay, so we have that word problem. All right, are there any questions on this? Okay, is anyone talking in the chat? Let me just see. Okay, so I think we're good with that. Okay, so let me keep going then. I just stopped it to check the chat to see if people wrote something. Okay. All right, so let's move on to the next one down here. Here we go. Okay, here we go. Okay, so now here's another one. We have a store, okay? A store is selling lemons at 2 of them for $1. You know, again, this comes from the textbook actually. And basically we're assuming, you know, somehow we can, you know, using the right juicer, each can give us 2 tablespoons of juice, lemon juice that is. I'm not saying it's realistic, I'm just saying that's what we're assuming. We want to know how much is it going to cost to buy enough, how much will it cost to buy enough lemons to make